As usual, this is a disclaimer. All shown ethical hacking and cybersecurity tips on this channel are for educational purpose only. Do not use any technique or method shown here on networks or machines that do not belong to you. Otherwise, you may expose yourself to legal actions. To help this channel, please subscribe, activate the bell, like, and share this video. Thank you for watching.
Today, we're diving deep into Python functions. Functions are essential building blocks of clean, reusable, and organized code. By the end of this video, you'll understand how to define functions, call them, work with parameters, and use return values, all with practical, meaningful examples. Let's dig in. Defining a function in Python. A function in Python is a named block of code designed to perform a specific task. You define it using the def keyword, followed by the function name, parentheses, and a colon. The code inside the function is indented and runs only when the function is called. This function, when called, by simply repeating its name followed by opening and closing parentheses, prints hello world to the console. Function can have parameters. Parameters are variables listed inside the parentheses in the function definition. They act as placeholders for values that you pass to the function when you call it. Example with parameters. Note that to expose the function parameter to print, you need to specify the parameter name into brackets inside the string, and you need to put an F before the first opening quote. Here, name is a parameter. When you call greet Alice, Alice is the argument passed to the function. In concern of types of parameters, Python supports several types of parameters. Positional parameters. The order of arguments matters. Keyword parameters. You specify arguments by name. Default parameters. You can set default values for parameters. Here is positional and keyword example. You can also define a default parameter. Here is an example. If no argument is provided, the default value is used. Sometimes you want your function to accept any number of arguments. Python allows this with asterisk args for positional arguments and double asterisk args for keyword arguments. Functions can return values using the return statement. This allows you to use the result of a function elsewhere in your code. You can return multiple values as a tuple, which can be unpacked into variables. Functions can even return other functions, which is useful for creating function factories. Let's look at some practical examples. This is an e-commerce price calculation. A function will calculate total price. Here is a user authentication function. Please note that this is just an example. In production, authentication functions are more complex and secure than this example. Let's talk about best practices. Use descriptive names for functions and parameters. Add dostrings to explain what your function does. Keep functions short and focused on a single task. Use return values to communicate results, not print statements. Here is a dostring example. Now we'll dive deep into Python modules and importing, a cornerstone of writing clean, reusable, and maintainable Python code. We'll cover what modules are, how to import and use them, real-world examples with standard and custom modules, best practices and advanced tips. Let's get started. A module in Python is simply a file containing Python definitions, functions, classes, and variables. Modules help you organize your code into logical, manageable pieces. For example, if you have a file called matchcodes P with some math functions, that file is a module. To use code from a module, you need to import it. Here is the simplest way. Here, we import the built-in math module and use its seat function to compute the square root of 9. When you import a module, Python loads it and creates a namespace, meaning you access its contents with module name, something. Sometimes, you only need specific functions or classes from a module. This way, now, you can use py and send directly without the math prefix. If a module name is long or you want a shorter name, uses this example, but you will notice that the file is underlined. If we run this code, it will throw an error because numpy is not installed. To fix it, just type in the terminal the command pip3 install numpy and then run the code again. We will now cover Python file operations, reading, writing, appending, and handling JSON data. These skills are essential for any real-world Python application, from data processing to configuration management. We need to understand file operations in Python. Files are used to store data permanently. Python provides powerful tools to read from, write to, and manipulate files efficiently. To work with files, you first need to open them using the open function. Always close files after use to free up resources. A quick tip: good to know, use the with statement for automatic closing. Here is an example to read the whole file into a single string. Greet for small files. Here is an example to read the whole file into a single string, great for small files. Here is an example showing how to read specific number of characters. Now let's dig right into files. Here is an example of reading a file. Be careful, this example will overwrite any existing file with the same name. Here is an example of appending a file. Here is an example of handling file exceptions. Always handle errors, especially when working with files that may not exist. Here is an example of real-world processing a log file. Suppose you have a server log file and want to count the number of error lines. Use case log analysis monitoring reporting. As you can see, we load all the logs and count the error occurrences, then display the count. Let's dig working with JSON files. JSON is the standard for data interchange. Python's JSON module makes it easy to read and write JSON data. Here is an example of writing a Python object to a JSON file. Indent equal 4 makes the file human readable. JSON stands for JavaScript Object Notation. It is a lightweight, text-based format used for storing and transmitting data between systems. Especially between a server and a web application, JSON is designed to be easy for humans to read and write and easy for machines to parse and generate. Key characteristics of JSON data is structured as name value pairs e. G. First name John. Objects are enclosed in curly braces. Arrays are enclosed in square brackets. Values can be strings, numbers, booleans, arrays, objects, or no. JSON is language independent, while its syntax is derived from JavaScript. It is supported by most modern programming languages. Here is a real-world example updating a JSON configuration. Suppose you want to toggle a user's active status in a config file. Now we will dig exception handling in Python, a crucial skill for writing robust, professional code. We'll cover the try, except, and finally blocks, show you how to use them effectively, and walk through real-world examples you'll actually encounter as a developer. Exception handling lets your program deal with unexpected errors gracefully, instead of crashing. In Python, this is done with the try, except, and finally statements. Look at the basic structure. The statement try stands for code that might fail. The statement except stands for what to do if it fails. The statement else stands for what to do if it doesn't fail. The statement finally stands for what to do no matter what, cleanup, closing files, etc. Here is why use exception handling. Without exception handling, your program will crash on the first error. With it, you can show helpful messages to users, clean up resources, close files, connections, handle different errors differently, keep your program running or exit gracefully. Let's say you want to read a file and process its content. Here is an example, and let's break down its behavior. If the file doesn't exist, file not found error is caught. If you don't have permission error is caught. If there are no errors, the else block runs. The finally block tries to close the file, whether or not an error occurred, ensuring cleanup. Here is another example of handling division by zero. Now we'll demystify Python classes and objects, the building blocks of object-oriented programming. Or OOP. By the end, you'll understand not just the syntax, but also why and how to use classes to write clean, reusable, and powerful code. What are classes and objects? Think of a class as a blueprint, like an architect's plan for a house. The object is the actual house built from that blueprint. In Python, almost everything is an object: numbers, strings, lists, and functions and modules. Class defines the structure and behavior, attributes and methods. Object, a specific instance created from a class with its own data. Let's start with a simple but meaningful example: modeling a dog. Here is why you should use classes. As your code base grows, classes help you encapsulate data and behavior together. Reuse code by creating multiple objects from one class. Abstract complexity, exposing only what's necessary. Organize code logically, making it easier to maintain. Let's look at a real-world example: a bank account class. This models a real bank account, encapsulating both data holder, balance, and behavior: deposit, withdraw, display. Now let's dig inheritance and polymorphism. Suppose we want to model different types of vehicles. We can create a vehicle-based class and a car subclass. Now car inherits from vehicle, reusing and extending its functionality as the example. Let's add a member that displays the number of the car doors. As you notice, the code crashed because I tried to mix numbers with strings. It is mandatory to convert the door's number to string. In polymorphism there will be one interface, multiple implementations. Suppose you have multiple classes with a method of the same name. This is polymorphism. The same interface behaves differently depending on the object. That's the essence of Python classes and objects. With these tools, you can write code that's cleaner, more organized, and easier to maintain. Experiment with your own classes, model things you care about, and see how OOP can make your code more powerful. Now we'll break down the essentials of computer networking: IP addresses, TCP/IP, ports, protocols, and then dive into real-world Python networking using the socket module. We'll use practical, meaningful examples to show how you can make connections and send-receive data in Python. Let's dig. What is a computer network? A computer network is a collection of devices, computers, servers, phones, etc., connected together to share resources and information. The Internet is the largest example, connecting billions of devices worldwide. IP address stands for Internet Protocol Address. It's a unique number assigned to every device on a network. Like a home address for your computer or phone, IPv4 numbers separated by dots. Example: 192.168.1.1, each from 0 to 255. IPv6 longer uses hexadecimal, designed to support more devices. Why do we need IP addresses? To identify devices on a network. To route data to the correct destination, just like a postal address ensures your letter reaches the right house. TCP/IP, the language of the Internet. TCP/IP stands for Transmission Control Protocol and Internet Protocol. It's a set of rules that governs how data is sent and received over networks. TCP ensures reliable, ordered delivery of data. IP handles addressing and routing, making sure data packets reach the right device. How does it work? Data is split into small packets. Each packet is sent independently and may take different routes. TCP reassembles packets in the correct order at the destination. If a packet is lost, TCP requests it again, ensuring nothing is missing. About ports and protocols organizing network traffic. Port is a logical channel for network communication, like an apartment number in a building. Each service uses a specific port: 80 HTTP web browsing, 443 HTTPS secure web, 25 SMTP email, 22 SSH secure remote access. Protocol: a set of rules for communication. Example: HTTP, FTP, SMTP. Why are ports important? They allow multiple services to run on a single device without confusion. Ports help direct incoming data to the correct application. Let's cover Python networking with the socket module. Python's socket module lets you create network connections, send and receive data. Let's see how it works with real examples. Let's make a simple TCP client. Let's connect to a web server and fetch a web page as this example. The part 2 of this crash course comes to its end. As you can notice, this course is not an exhaustive course. It aims to get fast notions about Python so we can move fast to the interesting projects. If you like Python and you would like to have a more advanced cutting-edge Python course, let me know in the comments section. See you in the next video.
To help this channel, please subscribe, activate the bell, like, and share this video. Thank you for watching.